The corrosion of iron heavily impacts the economy of U.S. Many iron objects, such as boats, have to be replaced because of the rust damage. The United States has estimated that the cost of metallic corrosion is around $70 billion. Rust deposits occur when air, water, and iron comes into contact to form a voltaic cell where an oxidation-reduction reaction takes place. Looking at these equations more closely, we can see the electron transfer which results in rust. 4 iron atoms react with 3 oxygen atoms and 2 water molecules to form the rust we see on the boat's hydrated iron oxide.
Oxygen is reduced to hydroxide ions on the surface of iron.
Iron is oxidized, losing 2 electrons. The iron 2+ ions combine with the hydroxide ions to form a precipitate of iron hydroxide. Dissolved oxygen quickly oxidizes this precipitate to rust. There are 2 types of galvanization: dipping and electrolysis. Electrolysis provides a more uniform zinc coating and exhibits no crystal patterns. The galvanization of iron using an electrolytic method will be demonstrated in this video. These are the materials required to perform the experiment.
Always wear your Chem goggles to be safe. Even if they're super blurry and you can't see out of them, still wear them.
Approximately 300 ml of DI water was added to a 400 ml beaker with 12 grams of ammonium citrate and 7.5 grams of ammonium chloride. Ammonium chloride is a strong electrolyte and added to improve the solution conductivity. Ammonium citrate served as a solution buffer which maintained the pH of the solution at about 4. The solution was mixed with a stirring rod until all solid had dissolved completely. Using alligator clips, the zinc strip was connected to the positive end of 6-volt battery and the iron nail was connected to the negative end. Both the zinc strip and the nail were placed into the solution for about 2 minutes without touching each other. After the experiment, the solution was poured down the drain with the water running. This is the nail right after the electrolysis. The left end of the nail is more shiny because it was dipped in solution and therefore plated in zinc. The following picture was taken a week after the experiment. The galvanization by electrolysis was successful because the parts of the nail plated by zinc exhibited no signs of rust, where the parts of the nail clearly did.
So, how does the nail get covered in zinc? When we connected the 2 metals with the battery, an electrolytic cell was created, producing an oxidation-reduction reaction. During the reaction, zinc was an anode and the iron nail was a cathode. As seen in the drawing, the anode was connected to the positive side of the battery, while the cathode was connected to the negative side. Electrons were transferred from the anode to the cathode. At the zinc anode, zinc metal dissolved to form zinc ions. The zinc ions then gain 2 electrons at the iron cathode and deposit themselves onto the iron nail. Why does zinc plating help iron not to rust? To explain, the standard reduction potential for the reduction of iron 2+ ions is less negative than that for the reduction of zinc 2+ ions. Therefore, iron 2+ is easier to reduce than zinc 2+. Conversely, zinc is easier to oxidize than iron. Zinc will be corroded instead of iron because it is the most easily oxidized, even if the zinc coating is broken. The metal that is oxidized in order to protect the cathode is called the sacrificial anode. In the galvanization of iron, zinc is the sacrificial anode. Iron had cathodic protection because zinc lost electrons more easily. These are the sources we used. Thanks for watching!